Welcome to the Sleep Scholar. Tonight, we'll explore a quiet corner of history together. Settle in, close your eyes, and let these gentle facts carry you into deep sleep. The standardization of ice block dimensions emerged as a practical necessity during these early years. Ice cutters discovered that blocks measuring approximately 22 inches in length, 11 inches in width, and 8 to 10 inches in thickness provided an optimal balance between handling convenience and efficient storage. These dimensions, which became widely adopted throughout New England ice cutting operations, allowed workers to lift and maneuver individual blocks without excessive physical strain, while maximizing the amount of ice that could be packed into storage facilities. The geographic concentration of early commercial ice cutting operations centered primarily around the greater Boston area, where numerous natural ponds provided suitable harvesting locations. Fresh Pond in Cambridge, Spy Pond in Arlington, and Wenham Lake in Wenham emerged as particularly important sources of high-quality ice. Wenham Lake ice, in particular, developed a reputation for exceptional clarity and purity, qualities that would later make it highly sought after in markets as distant as London and Calcutta. Weather conditions played a crucial role in determining the success or failure of each winter's ice harvest. Ice cutters required sustained periods of sub-freezing temperatures to produce ice thick enough for safe cutting operations. A minimum thickness of 4 inches was generally considered necessary for workers to venture onto the ice surface, though optimal cutting conditions required ice depths of 8 to 12 inches. Unusually mild winters, such as occurred in 1815 and 1819, could severely disrupt ice cutting schedules and result in significant financial losses for merchants who had committed to supply contracts. The labor force employed in early ice cutting operations reflected the seasonal nature of the work and the limited pool of available workers during winter months. Farm laborers constituted the primary source of ice-cutting personnel, supplemented by urban workers seeking temporary employment during economically challenging periods. Wages for ice-cutting work varied considerably depending on local conditions and the availability of workers, but records suggest that experienced ice cutters could earn between 75 cents and $1 per day, a reasonable wage for manual labor during this period. Safety concerns emerged early in the development of commercial ice cutting as workers faced numerous hazards associated with working on frozen pond surfaces using sharp tools in cold conditions. Accidental falls through thin ice represented perhaps the most serious risk, though injuries from cutting tools and the physical demands of lifting heavy ice blocks also posed ongoing concerns. Ice cutting crews developed various safety protocols, including the use of long poles to test ice thickness and the practice of working in pairs, so that assistance would be immediately available if a worker fell through the ice. The storage and preservation of harvested ice required the construction of specialized facilities known as ice houses. These structures, which began appearing around New England ponds in increasing numbers after 1810, were designed to maintain low temperatures and minimize ice melting during storage periods that could extend from winter harvest through the following autumn. Ice house construction involved thick wooden walls filled with sawdust or other insulating materials, raised foundations to improve air circulation, and carefully designed ventilation systems to prevent the accumulation of moisture that could accelerate melting. Transportation logistics presented another significant challenge for early ice merchants. The movement of heavy ice blocks from cutting sites to storage facilities and shipping points required robust sleds and reliable draft animals capable of operating effectively in winter conditions. Horse-drawn sleds fitted with wide runners to distribute weight and prevent sinking into snow became the standard method for moving ice from ponds to nearby ice houses. For longer distances, particularly transport to shipping docks, merchants sometimes waited for improved road conditions or utilized frozen rivers as transportation corridors. The expansion of Tudor's ice business beyond its initial Caribbean markets occurred gradually throughout the 1810s. Shipments to Charleston, South Carolina, began around 1817, followed by deliveries to Savannah, Georgia, and New Orleans, Louisiana. These domestic markets proved more receptive to ice shipments than the Caribbean destinations had initially been, as American consumers were generally more familiar with ice preservation techniques and more willing to pay premium prices for the convenience of year-round ice availability. The economic impact of commercial ice cutting on rural New England communities became increasingly apparent as the industry expanded during its first 15 years of operation. Pond owners discovered they could generate significant rental income by leasing ice-cutting rights to merchants, while local residents found new employment opportunities during the traditionally lean winter months. The demand for horses, sleds, cutting tools, and storage materials created additional economic activity in communities surrounding major ice-cutting operations. By 1820, the basic organizational structure and technological foundation of the American ice-cutting industry had been established. What had begun as Frederick Tudor's seemingly impractical experiment had evolved into a viable commercial enterprise, employing hundreds of workers and generating thousands of dollars in annual revenue. The techniques developed during this formative period would serve as the foundation for the massive expansion of ice-cutting operations that would characterize the following decades, when ice would become an essential commodity in American commerce and daily life. The systematic expansion of ice-cutting operations throughout New England during the 1820s and 1830s necessitated the development of highly regimented work schedules that could maximize efficiency during the brief winter harvesting season. Records from the Boston Ice Company indicate that by 1825, ice-cutting crews were operating under carefully orchestrated daily routines that began well before dawn and continued until the available daylight had been fully exhausted. The typical ice-cutting season in Massachusetts extended from late December through early March, though historians note that the most productive harvesting occurred during the coldest weeks of January and February, when ice thickness reached its optimal measurements of 12 to 18 inches. The standard workday for ice cutters commenced at approximately 4 o'clock in the morning when crew foremen would traverse the workers' boarding houses with lanterns, rousing the men from their sleep in preparation for the day's labor. Contemporary accounts from the Wenham Lake Ice Company suggest that workers were expected to consume their breakfast and report to the ice fields by 5:30, allowing them to begin cutting operations as soon as sufficient natural light became available. This early start proved essential given the limited daylight hours available during New England's winter months, with effective working time rarely extending beyond 4 o'clock in the afternoon. The morning routine typically began with a critical task of testing ice thickness across various sections of the harvesting area. Experienced ice cutters, often referred to as ice masters in company records, would use specialized boring tools to drill sample holes at regular intervals, ensuring that the ice had achieved the minimum thickness required for safe harvesting. Documentation from the Fresh Pond Iceworks in Cambridge indicates that ice measuring less than 10 inches in thickness was considered unsuitable for commercial cutting, as it posed both safety risks to workers and resulted in blocks that would deteriorate rapidly during storage and transport. Once ice thickness had been verified, crews would proceed with the methodical process of marking the ice surface into precise rectangular sections. This task, known as scribing, required considerable skill and experience, as a uniformity of the harvested blocks directly influenced both storage efficiency and commercial value. Workers employed specialized tools called ice plows, which consisted of metal blades mounted on wooden handles to score parallel lines across the ice surface at intervals of approximately 22 inches. The spacing of these lines had been carefully calculated to produce blocks weighing between 100 and 150 pounds, a size that could be handled efficiently by individual workers while maximizing storage density in ice houses. The scribing process typically consumed the first 2 hours of the workday, with teams of 4 to 6 men working in coordinated fashion to ensure that the marked sections remained properly aligned across the entire harvesting area. Records from the Spy Pond Ice Company indicate that experienced crews could complete the scribing process for an area of approximately 2 acres within this time frame, though adverse weather conditions such as snowfall or strong winds could significantly extend the duration of this preliminary work. Following the completion of scribing operations, ice-cutting crews would begin the physically demanding process of sawing through the ice along the marked lines. This work utilized specialized ice saws, featuring teeth specifically designed for cutting through frozen water, with blades measuring between 4 and 6 feet in length to accommodate the full thickness of harvestable ice. The sawing process required considerable physical strength and endurance, as workers were obliged to maintain steady, rhythmic motions while managing tools that could weigh up to 20 pounds when fully extended. The organizational structure of ice-cutting operations during this period reflected the need for precise coordination among workers performing different specialized tasks. Contemporary employment records from various New England ice companies reveal a hierarchical system that included ice masters who supervised overall operations, experienced cutters who performed the most skilled aspects of sawing, and block separation, and general laborers who handled transportation and loading duties. This division of labor allowed for the efficient processing of large quantities of ice while ensuring that each aspect of the harvesting process received appropriate attention from workers possessing the necessary skills and experience. The midday meal break typically occurred between 11:30 and 12:30, providing workers with an opportunity to warm themselves and consume the substantial quantities of food required to sustain their energy levels throughout the demanding workday. Boarding house records from the town of Wenham indicate that ice cutters typically consumed meals consisting of salt pork, beans, bread, and hot coffee, with some companies providing additional rations of beef or mutton during particularly strenuous harvesting periods. The caloric requirements for ice cutting work were considerable, with estimates suggesting that workers expended between 4,000 and 5,000 calories during a typical 12-hour shift. The afternoon work schedule focused primarily on the extraction and movement of cut ice blocks from the harvesting area to temporary storage locations adjacent to the ice fields. This process required the use of specialized tools, including ice tongs, which allowed workers to grip and maneuver blocks weighing up to 150 pounds, and ice slides, which consisted of wooden chutes that facilitated the movement of blocks from the cutting area to horse-drawn sledges for transport to permanent storage facilities. Weather conditions played a crucial role in determining the specific activities that could be accomplished during any given workday. Company records from the 1830s indicate that harvesting operations could continue effectively in temperatures ranging from 10 degrees above zero to 20 degrees below 0 Fahrenheit. However, extreme cold conditions below -20 degrees frequently resulted in tools becoming brittle and difficult to manage, while temperatures approaching the freezing point posed risks of ice, deterioration, and unsafe working conditions. Snow presented particular challenges for ice-cutting operations, as accumulations of more than 2 inches required removal before harvesting could commence. Ice companies employed teams of workers equipped with wooden scrapers and push brooms to clear snow from designated cutting areas, a process that could consume several hours, depending on the extent of snowfall and wind conditions. Records from the Rockland Lake Ice Company in New York suggest that snow removal operations typically required approximately 1 hour of labor per acre for each inch of accumulation. The evening routine for ice-cutting crews typically concluded between 4 and 5 o'clock in the afternoon, when diminishing daylight made continued work unsafe and inefficient. Workers were responsible for securing tools and equipment in designated storage areas and ensuring that partially completed cutting operations were properly marked to facilitate resumption of work the following morning. The return journey to boarding house accommodations provided an opportunity for workers to assess the day's productivity and discuss strategies for addressing challenges encountered during the harvesting process. Compensation structures for ice-cutting work varied considerably among different companies and geographical regions, though most workers received payment based on either daily wages or piece rate systems tied to the quantity of ice successfully harvested. Documentation from the Tudor Ice Company indicates that experienced ice cutters could earn between $1 and $1.50 per day during the peak harvesting season, wages that compared favorably with other forms of manual labor available during the winter months. However, the seasonal nature of ice cutting work meant that workers were obliged to seek alternative employment during the spring, summer, and fall months when harvesting operations ceased. The boarding house system, employed by most ice companies, provided accommodation and meals for workers during the harvesting season, though conditions in these facilities were generally austere and reflected the temporary nature of the employment arrangement. Historical accounts suggest that workers typically shared sleeping quarters with multiple roommates and were expected to observe strict regulations regarding noise, alcohol consumption, and adherence to work schedules. These boarding houses served not only as temporary residences but also as centers for the dissemination of information regarding work assignments, weather conditions, and changes in company policies or procedures. The technological innovations that emerged during the 1830s and 1840s began to influence the daily routines of ice-cutting operations, though the fundamental structure of the workday remained largely unchanged. The introduction of horse-drawn ice plows allowed for more rapid completion of scribing operations, while improvements in saw design reduced the physical demands associated with cutting through thick ice. However, the seasonal constraints and weather dependencies that characterized ice harvesting ensured that work schedules remained tied to natural conditions rather than industrial timetables. The social dynamics within ice-cutting crews reflected the diverse backgrounds of workers drawn to this seasonal employment opportunity. Company employment records indicate that ice-cutting operations attracted workers from various occupational backgrounds, including farmers seeking winter income, recent immigrants looking for entry-level employment, and skilled craftsmen supplementing earnings from other trades. This diversity contributed to the development of informal networks through which workers shared information about employment opportunities, working conditions, and strategies for managing the physical demands of ice-cutting labor. By the 1840s, the daily routines and work schedules that had evolved within New England's ice-cutting industry had become sufficiently standardized to serve as models for similar operations established in other regions of the United States. The systematic approaches to crew organization, task allocation, and time management developed during these formative decades would continue to influence ice harvesting operations throughout the remainder of the 19th century, establishing patterns of seasonal labor that would persist until the eventual mechanization of ice production rendered traditional cutting methods economically obsolete. These established patterns of labor organization naturally necessitated the development and refinement of specialized tools that could meet the demanding requirements of industrial ice harvesting. The evolution of ice-cutting implements during the mid-19th century represents a fascinating intersection of traditional craftsmanship and emerging industrial manufacturing techniques. Records from the Wenham Lake Ice Company, maintained in their Boston offices from 1844 onward, provide detailed inventories of the tools required for efficient ice harvesting operations, offering historians valuable insights into the technological progression of this seasonal industry. The ice saw, perhaps the most fundamental tool in any ice cutter's arsenal, underwent significant refinement during the 1840s and 1850s. Early ice saws, manufactured primarily by blacksmiths in New England communities, typically measured between 4 and 6 feet in length, with teeth spaced approximately 1 inch apart. The Diston Saw Works of Philadelphia, established by Henry Diston in 1840, began producing specialized ice saws by 1847, incorporating improvements suggested by experienced ice cutters from the Kennebec River operations in Maine. These saws featured reinforced spines to prevent bending under the lateral pressure created when cutting through ice of varying thickness and density. The teeth of professional ice saws required specific geometric configurations to achieve optimal cutting efficiency. Historians believe that the ideal tooth angle for ice cutting was determined through extensive experimentation conducted by crews working the Hudson River ice fields during the winter seasons of 1848 through 1851. Documentation from the Knickerbocker Ice Company indicates that saws with teeth set at a 15-degree angle produce cleaner cuts with less chipping along the ice block edges, a crucial consideration for commercial operations where uniformity directly impacted storage efficiency and transportation costs. The spacing between teeth also proved critical, with experienced cutters generally preferring teeth spaced at 7/8 of an inch for ice thickness ranging from 12 to 18 inches. Manufacturing records from the period reveal that quality ice saws commanded substantial prices, with professional-grade implements selling for approximately $3 to $5 each during the 1850s, representing nearly a week's wages for a typical ice cutter. The Sheffield Steel Works of Massachusetts, operating under the direction of Samuel Sheffield from 1852 to 1867, developed a reputation for producing exceptionally durable ice saws through the implementation of specialized tempering processes that enhanced the steel's resistance to the extreme temperature variations encountered during winter harvesting operations. It is said that Sheffield saws could maintain their cutting edge through an entire harvesting season without requiring resharpening, a significant advantage for operations located far from blacksmith shops or tool maintenance facilities. The scoring saw represented another essential category of cutting implement, designed specifically for creating the initial guide cuts that established the grid pattern for ice block removal. These tools, typically measuring 18 to 24 inches in length, featured finer teeth than their full cutting counterparts, with spacing reduced to approximately 5/8 of an inch. The Ames Manufacturing Company of Chicopee, Massachusetts, began producing specialized scoring saws in 1849, incorporating design improvements developed through consultation with foremen from the Fresh Pond ice operations near Cambridge. Records indicate that these scoring saws featured adjustable depth guides, allowing operators to maintain consistent cutting depths across the entire harvesting field, despite minor variations in ice surface level. Ice tongs, the primary tool for lifting and maneuvering individual ice blocks, evolved from simple blacksmith-forged implements into sophisticated lifting devices, engineered for specific load requirements and handling conditions. The basic ice tong design consisted of two curved arms connected by a pivot mechanism, with sharp points at the terminal ends designed to penetrate the ice surface and provide secure grip points. Manufacturing specifications from the Buffalo Forge Company, established in 1849, indicate that standard ice tongs measured approximately 30 inches in length and were capable of safely lifting ice blocks weighing up to 150 pounds when operated by an experienced worker. The metallurgy of ice tong construction required careful attention to the balance between strength and weight, as workers needed to manipulate these tools throughout extended work periods during harsh winter conditions. Documentation from the Elmira Ice Tool Works, operating in Elmira, New York, from 1854 to 1881, reveals that the most effective ice tongs incorporated carbon steel points with wrought iron handles, a combination that provided the necessary penetrating capability while maintaining sufficient flexibility to absorb the shock loads generated during lifting operations. The pivot mechanisms of quality tongs featured bronze bushings to ensure smooth operation even when ice particles accumulated in the joint areas. Specialized variations of ice tongs were developed for specific handling requirements encountered in commercial operations. Loading tongs, designed for transferring ice blocks from storage areas to transportation vehicles, typically featured extended handles measuring up to 4 feet in length, allowing workers to maintain safe distances from horse-drawn wagons and railroad cars during loading procedures. The Boston Ice Implement Company, founded by Jonathan Parker in 1856, manufactured a particularly innovative design of loading tongs that incorporated a mechanical advantage system, reducing the physical effort required to lift blocks weighing over 200 pounds. Records from the company's sales ledgers indicate that these specialized tools sold for approximately $8 per pair, nearly double the cost of standard ice tongs. Measuring equipment played an equally crucial role in maintaining the standardization required for efficient commercial ice operations. Ice rulers, typically constructed from seasoned hardwood with brass reinforcement strips, were used to verify block dimensions and ensure consistency across harvesting operations. The standard commercial ice block during the 1850s measured approximately 22 inches long, 14 inches wide, and 12 inches thick, dimensions that represented an optimal balance between handling convenience and storage efficiency. Manufacturing records from the Concord Tool Company of New Hampshire indicate that their ice rulers featured graduated markings etched at half-inch intervals, allowing workers to quickly assess whether individual blocks met commercial specifications. Ice thickness gauges represented another essential category of measuring equipment, as the determination of optimal cutting conditions depended upon accurate assessment of ice depth across the harvesting field. These instruments, resembling oversized calipers with graduated scales, allowed foremen to systematically evaluate ice thickness at multiple locations before authorizing the commencement of cutting operations. The Watertown Arsenal, primarily known for military manufacturing, produced civilian ice thickness gauges from 1851 to 1858, under contract with several New England ice companies. Documentation suggests that these precision instruments were capable of measuring ice thickness to within 1/8 of an inch, a level of accuracy that proved essential for operations harvesting ice intended for long-distance transportation. The maintenance and care of ice-cutting tools required systematic attention throughout the harvesting season, as the extreme conditions encountered during winter operations imposed significant stress on metal implements. Tool maintenance procedures developed by the crews working the Squam Lake operations in New Hampshire during the 1850s became widely adopted throughout the industry. These procedures specified daily inspection routines for identifying signs of metal fatigue, systematic sharpening schedules for maintaining cutting edges, and proper storage techniques for preventing rust and corrosion during periods of non-use. Records indicate that well-maintained tools could remain serviceable for 5 to 7 harvesting seasons, representing a substantial economic advantage for operations that implemented comprehensive maintenance programs. Sharpening techniques for ice saws required specialized knowledge of metallurgy and file work, skills that were typically concentrated among senior crew members who served as designated tool maintenance specialists. The proper sharpening of an ice saw involved not only the restoration of cutting edges, but also the maintenance of proper tooth set, the slight outward bending of alternating teeth that created the kerf width necessary for efficient cutting. Documentation from the Monadnock Ice Company suggests that improperly sharpened saws could reduce cutting efficiency by as much as 30%, directly impacting the productivity of harvesting operations and potentially compromising the economic viability of smaller ice companies operating with limited profit margins. The procurement and distribution of specialized ice-cutting tools created opportunities for regional manufacturing businesses that developed expertise in serving this seasonal industry. The Bellows Falls Tool Works of Vermont, operating from 1853 to 1889, specialized exclusively in the production of ice harvesting implements, maintaining detailed correspondence with ice companies throughout New England to identify opportunities for tool improvements and design modifications. Their manufacturing catalog from 1860, preserved in the Vermont Historical Society archives, lists over 40 different specialized tools for ice harvesting operations, ranging from basic hand implements to complex mechanical devices for large-scale commercial operations. This level of specialization reflects the sophisticated technological requirements that had emerged within the ice industry by the middle of the 19th century, transforming what had once been a simple seasonal activity into a complex industrial operation, requiring significant capital investment in specialized equipment and tools. The sophisticated equipment that had evolved by the 1850s naturally gave rise to equally sophisticated harvesting techniques that varied considerably depending on the scale of the operation, the geographical location, and the specific market demands of individual ice companies. The anatomy of these techniques reveals a careful orchestration of human labor, mechanical precision, and environmental knowledge that took decades to perfect across the major ice-producing regions of North America. The fundamental principle underlying all commercial ice harvesting techniques was the creation of uniform blocks that could be efficiently stored, transported, and utilized by end consumers. This uniformity requirement, historians believe, was first systematically addressed by Frederick Tudor's operations on Fresh Pond in Cambridge, Massachusetts, around 1825, when Tudor's workers began using measuring poles to ensure consistent block dimensions of approximately 22 inches by 16 inches by 10 inches thick. These dimensions were not arbitrary, but represented careful calculations based on storage efficiency, handling capacity for individual workers, and the melting characteristics that Tudor had observed during his early experimental shipments to the Caribbean markets. The actual harvesting process began with the critical technique of ice field preparation, which required workers to clear snow from the ice surface using specialized snowplows pulled by teams of horses. Records from the Knickerbocker Ice Company operations on the Hudson River indicate that snow clearing typically commenced when ice thickness reached approximately 8 inches, though harvesting would not begin until the ice achieved a minimum thickness of 12 inches. The cleared ice surface was then subjected to a process called candling, whereby experienced ice cutters would examine the ice for air bubbles, cracks, or other imperfections that might compromise the structural integrity of the harvested blocks. The marking technique represented perhaps the most crucial phase of the harvesting process, requiring the methodical scoring of the ice field into a precise grid pattern. This operation typically employed the ice marker, a wheeled device equipped with sharp cutting teeth, which was pulled across the ice surface by horses following carefully measured guidelines. The standard technique, as documented in ice company manuals from the 1870s, involved creating parallel lines spaced exactly 22 inches apart, running the entire length of the harvesting field, followed by perpendicular lines creating the cross-hatched pattern that would guide subsequent cutting operations. Historical accounts from the Morse Ice Company operations in Maine describe the meticulous process by which foremen would use surveying techniques borrowed from railroad construction to ensure that the marking lines maintained perfect geometric precision across ice fields that sometimes extended over several acres. The marking process for a typical 2-acre harvesting field required approximately 4 hours of continuous work by teams of 2 horses and 3 workers, with the lead worker responsible for maintaining the straightness of the lines, while the 2 assistants managed the horses and adjusted the marking equipment as necessary. The cutting technique itself represented the culmination of decades of experimentation with different approaches to separating individual ice blocks from the continuous ice sheet. The most widely adopted method by the 1860s involved a two-stage cutting process that began with the scoring technique, using hand-operated ice plows to deepen the marked lines to approximately half the total ice thickness. This initial scoring operation required considerable skill, as cutting too deeply risked premature separation of blocks, while insufficient cutting depth would complicate the subsequent separation process. The second stage of the cutting technique employed the ice saw to complete the separation process along the scored lines. Professional ice cutters developed highly specialized sawing techniques that varied depending on ice conditions, with experienced workers capable of adjusting their sawing rhythm and blade angle to accommodate variations in ice density and crystal structure. Documentation from the American Ice Company suggests that skilled ice sawyers could complete the cutting of a standard block in approximately 2 minutes and 30 seconds under optimal conditions, though this timing could extend significantly in cases where the ice exhibited unusual hardness or contained excessive air pockets. The prying technique used to separate completed blocks from the ice field required careful coordination between multiple workers using specialized prying bars and ice hooks. The standard approach involved inserting prying bars into the cut channels at strategic points around each block, with workers applying leverage in a coordinated sequence to gradually lift the block from its position without damaging adjacent blocks or the underlying ice sheet. Records from ice harvesting operations in Wisconsin indicate that the prying process typically required teams of 4 workers per block, with the lead worker directing the timing and sequence of leverage application, while the other 3 workers provided the necessary physical force. The floating technique represented an ingenious solution to the challenge of moving heavy ice blocks from the cutting area to the loading area without the use of wheeled vehicles that would be impractical on the ice surface. This technique involved creating channels of open water within the ice field by removing selected blocks in a predetermined pattern, creating waterways through which subsequent blocks could be floated using long poles and hooks. The floating channels typically measured approximately 4 feet in width and were positioned to provide the most efficient pathway from the cutting areas to the ice houses or loading platforms located at the shoreline. Historical documentation suggests that the floating technique was first developed systematically by ice companies operating on Lake Champlain in Vermont around 1835, where the large scale of harvesting operations made traditional manual transport methods impractical. The Vermont operations demonstrated that ice blocks could be efficiently guided through the water channels using techniques adapted from log driving operations, with workers stationed at strategic points along the channels to maintain the flow of blocks and prevent jams or blockages that could halt the entire operation. The elevation technique addressed the challenge of lifting ice blocks from the water level to ice houses or storage platforms that were necessarily built above the high water mark. The most common approach involved the use of inclined ramps equipped with mechanical conveying systems, typically consisting of endless chains fitted with specially designed hooks or cleats that could engage the ice blocks and draw them up the incline. These conveying systems were often powered by horses walking in circular patterns to turn large gear wheels, though some of the more advanced operations had begun experimenting with steam-powered elevation systems by the 1870s. The stacking technique within ice houses required careful attention to air circulation, drainage, and insulation principles that had been developed through decades of trial and error by ice storage operators. The standard stacking method involved placing blocks in tight formation with minimal air gaps, while maintaining small channels for air circulation and providing adequate drainage for meltwater. Workers skilled in icehouse stacking could typically position blocks with remarkable precision, ensuring that the weight of upper layers was evenly distributed and that the overall stack structure remained stable throughout the storage period. Documentation from the Chicago ice storage facilities indicates that proper stacking technique could reduce ice loss during storage by as much as 30% compared to improper stacking methods, making the skill of experienced ice house workers a valuable asset for commercial operations. The stacking process also incorporated the strategic placement of insulating materials, typically sawdust or hay, between layers and around the perimeter of the stack to minimize heat transfer and extend the storage life of the harvested ice. Regional variations in harvesting techniques developed in response to local environmental conditions and market requirements, with ice operations in different geographical areas adapting the basic methods to accommodate factors such as ice thickness variations, local labor availability, and transportation infrastructure. The techniques employed by ice harvesters working the lakes of northern Michigan, for example, differed significantly from those used by operations along the Kennebec River in Maine, reflecting the different ice conditions and logistical challenges encountered in these diverse environments. The seasonal timing of these various techniques required ice company foremen to maintain constant awareness of weather conditions and ice formation patterns, as the window of optimal harvesting conditions was often quite limited and could be dramatically affected by unexpected temperature fluctuations or snowfall. Records indicate that successful ice harvesting operations typically maintained detailed weather logs and ice thickness measurements throughout the winter season, allowing them to mobilize their full workforce and equipment at the precise moment when conditions were most favorable for efficient harvesting operations. This careful coordination of technique, timing, and resources represented the culmination of the industrial development that had transformed ice harvesting from a simple seasonal activity into a sophisticated commercial enterprise requiring considerable expertise in multiple specialized areas of knowledge and practice. The sophisticated commercial enterprise that ice harvesting had become by the mid-19th century created equally complex challenges regarding the accommodation and management of the substantial workforce required during the brief but intensive harvest seasons. Records from the Kennebec Ice Company indicate that during peak operations in the 1880s, individual ice houses along the Kennebec River in Maine employed between 300 and 600 workers during the 6 to 8 week cutting season, which typically commenced in late December and concluded by mid-February, depending upon weather conditions and ice thickness measurements. Larger operations, such as those conducted by the American Ice Company along the Hudson River, typically maintained better facilities due to their greater financial resources and the need to attract workers in competition with other industrial employers in more densely populated areas. Smaller companies operating in more remote locations often provided more basic accommodations, sometimes consisting of little more than converted barns or hastily constructed temporary shelters. Regional differences in housing arrangements reflected local conditions and labor markets. In areas of Maine, where ice companies operated near established towns, workers might secure private lodging in local boarding houses or with families who supplemented their income by renting rooms during the harvest season. Town records from Richmond, Maine, indicate that during the peak years of ice harvesting in the 1880s, approximately 1/3 of local households provided some form of accommodation to seasonal ice workers, charging between $4 and $6 per week for room and meals. The transient nature of much of the ice harvesting workforce created ongoing challenges for company management. Personnel records from various ice companies document high rates of worker turnover, with many individuals leaving before the completion of the season due to the physically demanding nature of the work, harsh living conditions, or opportunities for higher wages elsewhere. The Kennebec Ice Company's employment records for the 1883 season show that of the 420 workers hired at the beginning of the season, only 260 remained for its completion 6 weeks later. To address labor shortages and maintain workforce stability, some ice companies developed relationships with employment agencies in major cities, particularly Boston and New York. These agencies recruited workers from among recent immigrants and urban laborers seeking temporary employment. Company correspondence preserved in the archives of the Maine Historical Society includes contracts between the Androscoggin Ice Company and a Boston employment agency that agreed to supply 50 workers for the 1876 season, with the agency guaranteeing replacement of any workers who left before the season's completion. The employment patterns in ice harvesting also reflected broader demographic trends of the late 19th century. Immigration records indicate that a significant portion of the seasonal ice workforce consisted of recent immigrants, particularly from Ireland, French Canada, and later from Southern and Eastern Europe. These workers were attracted by the relatively high daily wages available during the ice season, despite the temporary nature of the employment. Payroll records from the Consumers Ice Company, which operated along the Kennebec River, show that during the 1889 season, approximately 40% of their workforce consisted of French-Canadian workers who had traveled south specifically for the ice harvest. The seasonal employment patterns in ice harvesting created ripple effects throughout local economies. Towns that served as centers for ice harvesting operations experienced significant population fluctuations during the winter months, straining local services and infrastructure, while simultaneously providing economic benefits to merchants, boarding house keepers, and other service providers. Municipal records from Gardiner, Maine, document complaints from local officials about the increased demands on sanitation services and law enforcement during the ice season, while simultaneously noting the substantial increase in local business activity and tax revenues. Working conditions in the boarding houses were generally austere and sometimes problematic. Contemporary newspaper accounts and company correspondence reveal ongoing issues with overcrowding, inadequate sanitation, and conflicts between workers from different ethnic and regional backgrounds. A report in the Kennebec Journal from January 1884 described conditions at one boarding house where 48 workers were housed in a structure originally designed for 30, resulting in workers sleeping in shifts and frequent disputes over space and resources. The temporary nature of these housing arrangements meant that little attention was paid to comfort or amenities beyond basic survival needs. Workers typically slept fully clothed due to cold temperatures and the early morning wake-up schedule. Personal hygiene facilities consisted of communal wash basins filled with cold water, and workers were expected to manage their own laundry needs, often hanging wet clothes near the heating stoves to dry overnight. Some ice companies attempted to improve worker satisfaction and retention by enhancing housing conditions and providing additional amenities. The Crystal Ice Company, operating near Augusta, Maine, constructed what contemporary accounts described as model boarding houses featuring individual sleeping rooms for 4 workers each, rather than the typical dormitory-style arrangements. These facilities also included a dedicated dining hall, separate from the sleeping quarters, and a recreational room, equipped with tables for card games and reading materials. Despite these improvements, the fundamental challenges of seasonal employment in ice harvesting remained constant throughout the industry's peak years. The brief, intensive nature of the work season, combined with the physically demanding conditions and remote locations of many operations, continued to make worker recruitment and retention ongoing concerns for ice company management. These challenges would persist until the gradual decline of natural ice harvesting in the early 20th century, as mechanical refrigeration technology began to replace the demand for naturally harvested ice in commercial and residential applications. This technological transition that would eventually render ice harvesting obsolete was still decades away when Frederick Tudor first conceived his revolutionary vision in the early years of the 19th century. Born in Boston on September 4th, 1803, Tudor came from a prosperous merchant family that had established itself in the shipping and trade industries throughout New England. His father, William Tudor Sr., had built a successful law practice and invested heavily in various commercial ventures, providing young Frederick with both the capital and the entrepreneurial mindset that would prove essential to his future endeavors in the ice trade. Tudor's initial inspiration for the ice business reportedly came during the summer of 1805, when he was merely 22 years old. According to historical accounts preserved in the Tudor family papers, Frederick was attending a social gathering where guests were complaining about the oppressive heat and expressing wishes for something cold to drink. It was during this conversation that Tudor purportedly conceived the idea of shipping ice from New England's frozen ponds and lakes to the warm climate regions of the Caribbean and southern United States, where such a commodity would command premium prices. The young entrepreneur's first serious attempt at ice exportation began in 1806 when he chartered a brig called the Favorite for a voyage to the island of Martinique. Tudor loaded the vessel with approximately 130 tons of ice, harvested from a pond near his family's estate in Saugus, Massachusetts. The ice was packed in sawdust and hay, primitive insulation methods that Tudor hoped would preserve the cargo during the lengthy ocean voyage. Unfortunately, this maiden voyage proved to be a commercial disaster, as nearly 70% of the ice melted before reaching its destination, and the remaining product found little market demand among the local population, who had no experience with ice consumption or preservation. Despite this initial setback, Tudor persisted in his efforts to establish an ice export business, though his early years were marked by repeated failures and mounting debts. Historical records indicate that between 1806 and 1815, Tudor made numerous unsuccessful attempts to create sustainable markets for New England ice in various warm climate destinations. His ventures to Cuba, Jamaica, and other Caribbean islands consistently resulted in financial losses, as the combination of inadequate preservation techniques, insufficient market development, and logistical challenges proved overwhelming for the nascent industry. The turning point in Tudor's fortunes came gradually through a series of innovations and market developments that occurred during the 1800s. First, Tudor began to invest significant time and resources into improving ice preservation methods during transport. Working with ship captains and cargo specialists, he developed more sophisticated packing techniques that utilized combinations of sawdust, rice chaff, and specially designed wooden containers to minimize melting during ocean voyages. These improvements typically reduced ice loss during shipping from the initial 70% to approximately 30 to 40%, making the business model substantially more viable. Equally important was Tudor's recognition that successful ice marketing required extensive consumer education and infrastructure development in destination markets. Beginning around 1816, Tudor began establishing ice houses and distribution networks in target cities before shipping large quantities of ice. He would typically send advance agents to construct insulated storage facilities, negotiate with local merchants for distribution partnerships, and conduct promotional campaigns to introduce potential customers to the benefits of ice consumption. This systematic approach to market development represented a significant departure from his earlier strategy of simply shipping ice and hoping to find buyers upon arrival. Tudor's breakthrough success came in 1817 with his expansion into the Calcutta market in British India. The East India trade route offered several advantages over his previous Caribbean ventures, including longer voyage times that allowed for more predictable business planning, a large expatriate British population already familiar with ice consumption, and a colonial administration that provided more stable commercial conditions. Tudor's first successful shipment to Calcutta departed from Boston in May 1817 aboard the ship Tuscany, carrying approximately 180 tons of ice packed according to his improved preservation methods. The Calcutta venture proved profitable enough to encourage continued expansion, and by 1820, Tudor had established regular ice shipping routes to several major ports in India and the Far East. Records from the Boston Custom House indicate that Tudor's company was shipping approximately 3,000 tons of ice annually by this time, with individual cargoes ranging from 150 to 300 tons, depending on vessel capacity and market demand. The ice was harvested primarily from Fresh Pond in Cambridge, Massachusetts, and Wenham Lake in Wenham, Massachusetts, both of which became famous throughout the industry for producing exceptionally clear, dense ice that commanded premium prices in international markets. As Tudor's business expanded and became more profitable during the 1820s, he began to invest heavily in improving the efficiency and scale of ice harvesting operations. Rather than relying on small-scale cutting operations managed by independent contractors, Tudor began establishing company-owned harvesting facilities that could produce ice according to standardized quality specifications. These operations typically employed between 50 and 100 workers during peak harvesting season, with specialized teams responsible for cutting, loading, transportation, and storage activities. The technical innovations introduced by Tudor's organization during this period had lasting impacts on ice harvesting practices throughout New England. His crews developed improved ice cutting techniques that produced more uniform blocks with standardized dimensions, typically measuring approximately 22 inches by 16 inches by 10 inches and weighing between 60 and 70 pounds. These standard dimensions allowed for more efficient packing in ships' holds and simplified handling procedures at destination ports. Tudor's operations also pioneered the use of specialized ice-cutting tools, including improved ice saws with teeth designed specifically for cutting through frozen water, and ice tongs engineered to provide secure gripping of smooth ice blocks during loading operations. By the early 1830s, Tudor had achieved sufficient success and market dominance to earn the nickname Ice King, a title that reflected both his commercial achievements and his somewhat imperious personality in business dealings. Contemporary accounts describe Tudor as a demanding and detail-oriented businessman who maintained strict control over all aspects of his operations, from harvesting techniques to international marketing strategies. He reportedly insisted on personally inspecting ice quality at harvesting sites and maintained extensive correspondence with agents and distributors throughout his global network of markets. Tudor's success attracted numerous competitors during the 1830s and 1840s, leading to increased competition and market expansion throughout the ice trade industry. However, Tudor maintained significant advantages over his rivals through his established distribution networks, superior preservation techniques, and long-term contracts with major customers in key markets. By 1840, industry records suggest that Tudor's operations controlled approximately 60% of the international ice trade, with annual revenues exceeding $100,000, a substantial fortune by the standards of that era. The expansion of Tudor's business during the middle decades of the 19th century had profound impacts on ice harvesting communities throughout Massachusetts and other New England states. Towns such as Wenham, Saugus, and Cambridge became major centers of ice production, with local economies increasingly dependent on seasonal harvesting activities. Tudor's operations provided employment for hundreds of workers during winter months, including not only ice cutters, but also teamsters, warehouse workers, shiploaders, and various support personnel required for large-scale commercial harvesting. The working conditions in Tudor's ice harvesting operations were generally similar to those found throughout the industry, though his larger scale of operations sometimes allowed for slightly better organization and equipment than smaller independent operations. Workers typically earned between $1 and $1.50 per day during peak harvesting season, wages that were competitive with other forms of manual labor available during winter months. Tudor's operations were notable for their emphasis on efficiency and productivity, with work crews expected to maintain demanding daily quotas for ice cutting and loading activities. As Tudor aged and his business matured during the 1850s, he began to delegate increasing responsibility to subordinates while maintaining overall strategic control of the company. His organization had evolved into a sophisticated commercial enterprise with permanent offices in Boston, established agents in major international markets, and contractual relationships with dozens of harvesting sites throughout New England. The success of Tudor's business model had demonstrated the viability of large-scale natural ice commerce and inspired the development of similar operations throughout the northern United States. The establishment of these commercial networks created an immediate and pressing need for efficient transportation systems capable of moving massive quantities of ice from remote harvesting locations to urban distribution centers and shipping ports. The success of Tudor's enterprise, along with the dozens of competing operations that emerged throughout the 1840s and 1850s, fundamentally depended upon the development of reliable methods for transporting ice blocks that could weigh anywhere from 50 to 300 pounds each, depending upon the cutting specifications required by different markets. The earliest transportation method employed by ice harvesters relied upon teams of draft horses pulling specially constructed wooden sleds across the frozen surfaces of lakes and ponds. Historical records from the Kennebec River ice operations in Maine indicate that a typical harvesting crew would employ between 12 and 20 horses during peak cutting season, with each animal capable of pulling approximately 1,500 pounds of ice blocks on properly maintained sled runners. The horses used in ice cutting operations were predominantly Percheron and Clydesdale breeds, selected for their substantial body weight and steady temperament in cold weather conditions that frequently reach temperatures of 10 to 20 degrees below 0 Fahrenheit. The construction of ice sleds represented a specialized craft within the broader ice industry, requiring carpentry skills adapted specifically to the unique demands of transporting heavy loads across irregular ice surfaces. Main shipbuilders, particularly those operating in Bath and Brunswick, became renowned throughout New England for their ice sled construction, utilizing techniques borrowed from traditional boat building to create runners that could flex and bend without breaking when encountering pressure ridges or thin ice sections. These sleds, which typically measured 12 to 16 feet in length and 4 to 6 feet in width, featured curved runners made from oak or hickory wood that had been steamed and bent into shape using methods similar to those employed in creating ship hulls. The daily routine of ice transportation began before dawn, when stable crews would harness the draft horses and prepare the sleds for the day's hauling operations. Historians studying the Rockland Ice Company's operational records from 1847 indicate that a typical transportation crew consisted of one teamster responsible for managing 2 horses and 1 sled, with experienced teamsters capable of completing between 8 and 12 round trips per day between the cutting site and the storage houses located along the shoreline. The distance of these trips varied, considerably depending upon the specific geography of each harvesting location, but records suggest that most operations maintained cutting sites within 1/4 mile of their storage facilities to minimize transportation time and reduce the risk of ice block damage during transport. The loading process itself required considerable skill and coordination among crew members, as ice blocks needed to be positioned on the sleds in configurations that would prevent shifting during transport, while maximizing the total weight that could be moved in each trip. Experienced ice cutters developed standardized loading patterns, typically arranging blocks in alternating orientations, so that the natural irregularities in each piece would interlock with adjacent blocks and create a stable load. The New England Ice Company's training manual from 1852 specified that blocks should never be stacked more than 3 layers high on transportation sleds, as higher stacks created an unacceptable risk of the entire load shifting and potentially injuring the horses or damaging valuable ice inventory. Weather conditions played a crucial role in determining the effectiveness of horse-drawn transportation methods, with optimal conditions occurring when temperatures remained consistently below 20 degrees Fahrenheit and fresh snowfall provided adequate traction for both horses and sled runners. Warm weather presented particular challenges, as temperatures above 30 degrees could cause ice blocks to begin melting and fusing together during transport, creating loads that were difficult to unload at storage facilities. Conversely, extremely cold conditions, particularly those accompanied by strong winds, could cause horses to tire more quickly and require more frequent rest periods, reducing the total number of loads that could be transported during a typical working day. The expansion of railroad networks throughout New England during the 1850s created new opportunities for ice transportation that fundamentally transformed the economics of the industry. The construction of the main Central Railroad, completed in stages between 1851 and 1857, provided direct rail connections between major ice harvesting regions along the Kennebec River and shipping ports in Portland and Boston. Railroad transportation offered several significant advantages over horse-drawn methods, including the ability to move substantially larger quantities of ice in single shipments and reduce dependence upon favorable weather conditions for transportation operations. The adaptation of railroad cars for ice transportation required the development of specialized freight cars designed to accommodate the unique requirements of ice cargo. The Boston and Maine Railroad, working in collaboration with the Consumers' Ice Company, developed the first standardized ice cars in 1854, featuring reinforced floors capable of supporting loads exceeding 20,000 pounds and drainage systems designed to channel meltwater away from the cargo area. These cars, which measured approximately 36 feet in length and 8 feet in width, could accommodate between 15 and 20 tons of ice blocks, representing the equivalent of approximately 12 to 15 horse-drawn sled loads. Loading railroad cars presented different challenges compared to sled loading, as the height of the car floors required the construction of permanent loading platforms at major harvesting sites. The Knickerbocker Ice Company invested approximately $8,000 in 1856 to construct a loading facility at their Squirrel Island operation, featuring a raised platform that extended for more than 200 feet along the railroad siding and included a system of wooden chutes that allowed workers to slide ice blocks directly from temporary storage areas into waiting freight cars. This facility could accommodate the simultaneous loading of 6 railroad cars and typically required a crew of 24 workers to complete the loading of a full train, consisting of 12 to 15 cars. The coordination between railroad schedules and ice harvesting operations required careful planning and communication between company managers and railroad officials. Historical records from the Eastern Railroad Company indicate that ice trains typically operated on predetermined schedules during peak harvesting season, with daily departures from major loading points along the Kennebec River and scheduled arrivals at distribution centers in Boston, New York, and Philadelphia. The reliability of these schedules depended heavily upon weather conditions, as severe winter storms could disrupt rail operations for several days and create significant backlogs of ice inventory at harvesting sites. Railroad transportation also enabled ice companies to expand their market reach beyond traditional coastal shipping routes, opening new opportunities for sales to inland cities and towns throughout the Northeast. The completion of rail connections to Albany, Syracuse, and Buffalo allowed Maine ice companies to compete directly with local ice harvesters operating on smaller lakes and ponds in New York State. Records from the American Ice Company suggest that railroad transportation reduced the delivered cost of Maine ice to inland markets by approximately 15 to 20% compared to the previous system of shipping ice by water to coastal ports and then transporting it inland using horse-drawn wagons. The integration of railroad transportation into ice industry operations created new employment opportunities for workers with specialized skills in railroad operations and freight handling. Many ice companies established permanent positions for railroad coordinators, individuals responsible for managing the complex logistics of coordinating harvesting schedules with train departures and ensuring that adequate supplies of ice were available for loading when trains arrived at harvesting sites. These positions typically required familiarity with both railroad operations and ice industry practices, and commanded salaries approximately 25 to 30% higher than typical ice-cutting wages. The continued use of horse-drawn transportation alongside railroad methods created a complex multimodal system that characterized ice industry operations throughout the 1860s and 1870s. While railroads provided efficient long-distance transportation, horses remained essential for moving ice from cutting sites to railroad loading points and for local distribution within urban markets. The Consolidated Ice Company of Boston maintained a stable of more than 60 horses in 1865, despite relying primarily upon railroad transportation for receiving ice shipments from Maine and New Hampshire harvesting operations. The management of horse-drawn operations required considerable expertise in animal husbandry and veterinary care, as the harsh working conditions and heavy loads associated with ice transportation created significant stress on draft animals. Company records indicate that experienced teamsters earned wages comparable to skilled craftsmen, reflecting the specialized knowledge required to maintain horses in productive condition throughout the demanding winter harvesting season. The care and feeding of draft horses represented a significant operational expense, with typical daily feed costs ranging from 75 cents to $1 per animal during winter months when hay and grain prices reached their seasonal peaks. These operational expenses necessitated substantial initial capital investment in icehouse infrastructure, facilities designed to preserve harvested ice through the warmer months when demand reached its peak. The construction of ice houses represented perhaps the most critical component of successful ice operations, as inadequate storage could result in complete loss of inventory regardless of how efficiently the harvest itself had been conducted. Records from the Kennebec Ice Company indicate that a typical commercial ice house capable of storing 10,000 tons required an initial construction investment of approximately $8,000 to $12,000 in the 1870s, a sum equivalent to the cost of several well-appointed residential properties. The fundamental principle underlying ice house design centered on the concept of thermal isolation, achieved through multiple layers of insulating materials and carefully engineered air circulation systems. Traditional ice house construction began with a selection of sites offering natural drainage and protection from direct sunlight, typically situated on elevated ground to prevent water accumulation during spring thaws. The Knickerbocker Ice Company's facilities along the Hudson River, constructed between 1868 and 1874, exemplified the standard approach to foundation preparation, with workers excavating to depths of 4 to 6 feet and installing drainage systems composed of field stones and gravel. The structural framework of commercial ice houses typically employed post and beam construction, utilizing locally sourced timber, with vertical supports spaced at intervals of 12 to 16 feet, depending on the intended storage capacity. documentation from the main. Ice Company's operations at Pemaquid Point describes the use of hemlock timbers, measuring 12 inches by 12 inches for primary supports, with secondary framing, constructed from 8-inch by 10-inch pine beams. These massive timber frameworks were designed to withstand not only the considerable weight of stored ice, but also the lateral pressures exerted by ice blocks as they settled and compressed during storage periods extending from February through September. Wall construction represented the most sophisticated aspect of ice house engineering, incorporating multiple layers of materials selected for their insulating properties and resistance to moisture penetration. The standard wall assembly, as documented in the technical specifications of the Boston Ice Company's Charlestown facility, completed in 1876, consisted of an exterior sheathing of rough sawn pine boards applied vertically, followed by a cavity filled with sawdust, wood shavings, or other organic insulating materials. A second interior wall of smooth planed boards created an air gap of typically 4 to 6 inches, which was also packed with insulating material, most commonly sawdust obtained from local lumber mills. The procurement and preparation of sawdust represented a specialized operation in itself, requiring careful attention to moisture content and particle size to achieve optimal insulating characteristics. Records indicate that sawdust with moisture content exceeding 20% proved ineffective for insulation purposes and could promote bacterial growth that accelerated ice deterioration. The Crystal Ice Company's operations in Portland, Maine, maintained exclusive contracts with 3 local sawmills to ensure adequate supplies of properly dried hardwood sawdust, paying premium prices of 15 to 20 cents per cubic yard for material that met their exacting specifications. Roofing systems for ice houses demanded careful engineering to shed precipitation while minimizing heat transfer from solar radiation. The predominant design featured steep-pitched roofs with slopes ranging from 8 in 12 to 10 in 12, constructed using traditional timber framing techniques with rafters spaced at 24-inch intervals. Roofing materials varied by region and local availability, though cedar shingles remained the preferred covering throughout New England ice operations due to their natural resistance to moisture and relatively low thermal conductivity. The Union Ice Company's facility at Rockland, Maine, completed in 1879, featured innovative double-roof construction with an airspace of 18 inches between the outer weather surface and an inner ceiling, providing additional thermal protection during summer months. Ventilation systems represented perhaps the most complex aspect of icehouse design, requiring precise balance between preventing warm air infiltration and allowing moisture vapor to escape without permitting excessive air circulation that could accelerate melting. The standard ventilation arrangement incorporated screened openings near ground level on the north-facing wall, with corresponding exhaust vents positioned near the ridgeline of the roof. These openings, typically measuring 2 feet by 4 feet, could be adjusted using sliding wooden covers operated from interior walkways, allowing icehouse supervisors to regulate airflow according to external temperature conditions and storage requirements. The interior layout of ice houses followed standardized patterns developed through decades of operational experience, with storage areas divided into sections or rooms separated by insulated partitions. Each room typically measured 30 feet by 40 feet and could accommodate approximately 500 tons of ice when filled to standard height of 14 to 16 feet. Narrow aisles or walkways, usually 4 feet in width, provided access for workers monitoring storage conditions and removing ice for shipment. These walkways featured raised wooden platforms to prevent contact with the inevitable accumulation of meltwater that collected on the storage room floors. Drainage systems within ice houses required sophisticated engineering to remove meltwater without compromising the building's thermal integrity. The conventional approach involved sloping the storage room floors toward central collection channels, typically constructed from wooden planking and lined with sheet metal to prevent water absorption into the structural timbers. These drainage channels connected to external systems that directed water away from the building foundation, often incorporating settling basins where sawdust and debris could be removed before final discharge. The Consumers Ice Company's facility at Bath, Maine, featured an innovative drainage system utilizing ceramic tiles imported from Massachusetts, representing one of the earliest applications of fired clay drainage products in icehouse construction. Temperature monitoring throughout ice houses relied on systematic observation rather than mechanical instrumentation, with experienced supervisors conducting daily inspections to assess storage conditions. These inspections focused primarily on visual examination of ice surfaces for signs of deterioration, measurement of meltwater accumulation, and evaluation of sawdust condition in areas where it came into direct contact with stored ice. Company records from the Eastern Ice Company indicate that skilled storage supervisors could predict ice loss rates with remarkable accuracy, typically estimating total seasonal shrinkage within 5% of actual measured losses. The loading and unloading of ice houses required specialized equipment and carefully planned procedures to minimize handling damage and maintain storage organization. Most facilities featured elevated platforms or docks positioned adjacent to storage areas, allowing horse-drawn wagons or railroad cars to be loaded efficiently using simple wooden chutes or mechanical conveyor systems. The Kennebec Ice Company's main storage facility, constructed in 1877, incorporated steam-powered endless chain conveyors capable of moving ice blocks from storage rooms to loading platforms at rates exceeding 200 tons per day. Capacity calculations for ice house design involved complex considerations of ice block dimensions, stacking procedures, and allowances for insulating materials between storage layers. Standard commercial ice blocks measuring 22 inches by 11 inches by 14 inches could be stacked efficiently in alternating patterns that maximized storage density while maintaining structural stability. Experienced icehouse designers typically calculated storage capacity, assuming 75 to 80% utilization of available cubic footage, with the remainder occupied by sawdust insulation, air spaces, and access requirements. The economic lifespan of icehouse structures typically ranged from 25 to 30 years, assuming proper maintenance and periodic renovation of insulating materials and structural components. Maintenance schedules developed by major ice companies called for annual inspection and replacement of exterior wall sections showing signs of moisture damage, complete replacement of sawdust insulation every 3 to 4 years, and systematic renovation of drainage systems to prevent ice contamination from standing water. The Turner Ice Company's Operations Manual, published in 1882, specified maintenance procedures requiring approximately 40 days of skilled labor annually for a facility storing 8,000 tons of ice. Construction costs for ice houses varied significantly based on storage, capacity, site conditions, and regional material prices, though industry records suggest consistent relationships between facility size and total investment requirements. Documentation from multiple New England ice companies indicates construction costs ranging from 60 cents to $1.25 per ton of storage capacity, with larger facilities achieving somewhat better economies of scale. These costs included site preparation, structural materials, labor, and initial installation of insulating materials, but excluded land acquisition and specialized handling equipment. Regional variations in ice house construction reflected local material availability, climate conditions, and established building traditions, though fundamental design principles remained remarkably consistent throughout the major ice-producing regions. Facilities constructed in the upper Midwest typically featured thicker wall assemblies and more sophisticated ventilation systems to accommodate longer storage periods and more extreme temperature variations. The Chicago Ice Company's storage facilities, completed between 1875 and 1881, incorporated double-wall construction with total thickness exceeding 18 inches, significantly greater than the typical 12-inch walls common in New England operations. The decline of natural ice harvesting in the early 20th century left numerous icehouse structures abandoned or converted to alternative storage uses, though a few continued operating into the 1920s as local suppliers serving rural communities without access to manufactured ice. Archaeological investigations conducted at former icehouse sites have revealed sophisticated construction techniques and material choices that enabled these structures to achieve remarkable thermal performance using entirely natural materials and traditional building methods, developed through systematic observation and gradual refinement over several generations of ice industry operations. These regional construction innovations reflected the broader geographical and economic factors that shaped ice-cutting operations across different areas of the northeastern United States and Great Lakes region during the 19th and early 20th centuries. New England ice operations, particularly those centered around the Kennebec River in Maine and various lakes throughout New Hampshire and Vermont, developed distinctly different characteristics from their Great Lakes counterparts in Michigan, Wisconsin, and northern New York. Records from the Maine State Archives indicate that by 1857, approximately 43 ice houses operated along a 30-mile stretch of the Kennebec River between Augusta and Gardiner, with individual facilities capable of storing between 8,000 and 25,000 tons of ice annually. The New England operations benefited from several geographical advantages that influenced their operational methods and market reach. The proximity to major shipping ports, particularly Boston, Portland, and Portsmouth, enabled Maine ice companies to develop extensive export markets that extended as far south as Charleston, South Carolina, and as far abroad as Calcutta, India. The Tudor Ice Company, founded by Frederick Tudor in 1806, established the foundational business model that many New England operations would follow, emphasizing long-distance transportation and premium pricing for high-quality natural ice. Historical shipping manifests from the Boston Custom House reveal that during the peak year of 1847, New England ice exports totaled approximately 65,000 tons, with individual shipments ranging from 50 tons for domestic coastal deliveries to 800 tons for international voyages to tropical markets. The physical characteristics of New England ice also distinguish these operations from those in other regions. The relatively shallow lakes and slow-moving rivers of Maine, New Hampshire, and Vermont typically produced ice with different crystal structures and purity levels compared to the deeper, more turbulent waters of the Great Lakes. Ice-cutting foremen in New England developed specialized techniques for evaluating ice quality based on visual clarity, with the clearest ice commanding premium prices in urban markets. Company records from the Knickerbocker Ice Company indicate that their main operations classified ice into 4 distinct grades, with first-grade ice selling for approximately $2.50 per ton at wholesale, while fourth-grade ice brought only 75 cents per ton in 1863. Great Lakes ice operations, by contrast, evolved under different geographical and economic pressures that shaped their operational characteristics in fundamental ways. The vast scale of the Great Lakes system, with Lake Michigan alone covering approximately 22,300 square miles, provided ice cutters with virtually unlimited harvesting areas, but also presented unique logistical challenges. Wisconsin ice companies, particularly those operating around Lake Geneva, Lake Mendota, and the numerous smaller lakes throughout the southeastern portion of the state, developed harvesting techniques specifically adapted to the deeper, more variable ice conditions typical of glacially formed lakes. The Milwaukee Sentinel reported in 1872 that Wisconsin ice operations employed an average of 12 men per harvesting crew, compared to the typical 8-man crews used by Maine operations, reflecting the more physically demanding conditions encountered on the Great Lakes. The market dynamics serving Great Lakes ice operations also differed significantly from the export-oriented New England model. Chicago, Detroit, Milwaukee, and other rapidly growing Great Lakes cities provided substantial local demand that could absorb the entire production of regional ice companies without requiring expensive long-distance transportation. The Chicago Ice Company, incorporated in 1864, operated harvesting sites on 11 different lakes throughout northern Illinois and southern Wisconsin, with company records indicating total annual production of approximately 130,000 tons by 1875. This production volume far exceeded that of most individual New England operations, but the Chicago Ice Company's customers were primarily local breweries, meatpacking plants, and residential ice dealers within a 50-mile radius of the city. Great Lakes ice operations also developed different approaches to mechanization and industrial efficiency. The abundance of suitable harvesting sites and the concentrated urban markets of the region encouraged investment in steam-powered ice-cutting equipment earlier than in many New England operations. The Consumers Ice Company of Detroit purchased its first steam-powered ice plow in 1868, approximately 4 years before similar equipment became common in main operations. Company correspondence preserved in the Detroit Public Library archives indicates that this mechanization decision was driven primarily by labor costs, as Detroit ice companies competed with rapidly expanding manufacturing industries for seasonal workers during the crucial winter harvesting months. The transportation infrastructure serving these two regions created additional operational distinctions that influenced everything from harvesting schedules to storage, capacity planning. New England ice companies relied heavily on coastal shipping, with specially designed ice schooners and steamships providing regular service between main ice ports and urban markets throughout the Atlantic seaboard. The ice schooner Helen Mar, built in Bath, Maine, in 1859, measured 112 feet in length and could carry approximately 400 tons of ice in specially constructed holds lined with sawdust and wood shavings. Maritime insurance records from Lloyd's of London indicate that ice cargo ships faced seasonal insurance rate variations, with winter coastal voyages carrying premiums approximately 40% higher than summer rates due to storm risks and the time-sensitive nature of ice cargo. Great Lakes ice transportation, conversely, depended primarily on railroad networks that connected harvesting sites to urban distribution centers. The Chicago and Northwestern Railway established dedicated ice freight rates in 1867, offering seasonal pricing that encouraged Great Lakes ice companies to develop harvesting sites along existing rail lines, rather than at locations chosen purely for ice quality considerations. Railroad company annual reports from this period indicate that ice freight typically represented between 8 and 12% of total winter cargo tonnage for rail lines serving Wisconsin, Michigan, and northern Illinois, making ice companies significant customers whose operational requirements influence railroad scheduling and equipment allocation decisions. These transportation differences also affected the seasonal timing of harvesting operations in the two regions. New England ice companies, dependent on coastal shipping, often extended their harvesting seasons later into the spring to take advantage of improved sailing conditions as winter storms subsided. Company logs from the Consumers Ice Company of Boston show harvesting operations continuing as late as March 15th in mild winters, with the final harvest stored primarily for local summer consumption rather than export markets. Great Lakes operations, constrained by railroad schedules that prioritized agricultural shipments during spring planting season, typically concluded their harvesting by early March regardless of ice conditions, leading to different storage capacity requirements and inventory management strategies. The labor markets serving these regional ice industries reflected the broader economic and demographic characteristics of their respective areas. New England ice operations drew workers primarily from local farming communities seeking winter employment during agriculturally inactive months. Payroll records from the Kennebec Ice Company indicate that approximately 68% of their seasonal workforce returned for multiple seasons, suggesting relatively stable employment relationships and accumulated expertise in ice cutting techniques. The average daily wage for experienced ice cutters in Maine during 1870 ranged from $1.25 to $1.75, depending on specific job responsibilities and weather conditions. Great Lakes ice companies faced different labor market dynamics, particularly in rapidly industrializing cities where winter employment opportunities existed in multiple industries. Records from the Maine Ice Association indicate that ice harvested along the Kennebec River could be sold in southern markets at prices 3 to 4 times higher than local New England rates. But such profits required substantial logistical coordination and the financial capacity to maintain quality during extended transportation periods. The most successful ice companies developed integrated operations that controlled harvesting, storage, transportation, and retail distribution, allowing them to capture margins at each stage of the supply chain. Labor costs represented approximately 20 to 30% of total ice company expenses, with wage structures that reflected the seasonal and physically demanding nature of the work. Skilled ice cutters in established operations like those at Lake Winnipesaukee in New Hampshire earned between $12 and $18 per week during peak harvesting periods, substantially higher than typical manufacturing wages of the era. But this employment lasted only 6 to 10 weeks annually. Companies reduced labor costs through the widespread use of temporary workers during harvesting seasons, avoiding the expense of year-round employment while maintaining access to experienced crews when needed. Market demand patterns exhibited strong correlation with urbanization rates and rising living standards throughout industrializing regions. The Chicago Ice and Cold Storage Company documented that per capita ice consumption in urban areas increased from approximately 100 pounds annually in 1860 to over 300 pounds by 1890, reflecting both population growth and changing consumer expectations regarding food preservation and comfort cooling. Commercial customers, including breweries, meat-packing facilities, and passenger railroad companies, represented the most stable and lucrative market segments, often consuming ice in quantities that dwarfed residential demand. Competition from artificial ice production began affecting natural ice pricing structures as early as the 1870s, though mechanical refrigeration initially served primarily specialized industrial applications rather than general consumer markets. The first commercial ice manufacturing plants, constructed in New Orleans and other southern cities, where natural ice transportation costs were prohibitive, produced artificial ice at costs approximately 50% higher than delivered natural ice prices, limiting early market penetration to situations where transportation logistics made natural ice impractical. Seasonal price volatility created both opportunities and challenges for ice distributors who needed to balance inventory management with rapidly changing market conditions. During exceptionally hot summers, retail ice prices could increase by 100% or more within a matter of days. But such price spikes often reduced overall demand as consumers curtailed non-essential ice usage. The New York Ice Exchange, established in 1883, attempted to stabilize pricing through coordinated inventory reporting and voluntary price guidelines among major regional suppliers, though enforcement mechanisms remained limited and price competition continued to characterize most local markets. International trade in natural ice represented a small but economically significant component of the overall market, with American companies exporting ice to Caribbean islands, India, and other tropical regions where local production was impossible. The Boston-based Tudor Ice Company maintained regular shipping routes to Havana, where American ice sold for prices reaching 10 to 15 cents per pound, generating profit margins that easily justified the substantial transportation costs and cargo losses inherent in such long-distance trade. Credit arrangements and financing structures evolved to accommodate the unique cash flow challenges facing ice companies, with specialized lending institutions developing expertise in evaluating seasonal business models. The Boston Ice Company Credit Association, formed in 1878, provided short-term loans to smaller operators during the critical spring and early summer months when expenses continued, but revenues had not yet materialized, charging interest rates that reflected the substantial risks associated with weather-dependent agricultural operations. The final decade of commercial ice cutting saw only scattered operations continuing in remote northern regions, where labor costs remained low and local demand still existed for inexpensive natural ice. Records indicate that by 1928, fewer than 24 commercial ice cutting operations remained active across the entire United States, producing less than 1 million tons annually, compared to mechanical ice production of approximately 18 million tons that same year. The economic collapse that began in 1929 eliminated most of the remaining natural ice operations, as reduced consumer spending and business failures destroyed the marginal markets that had sustained these final ice-cutting enterprises. The last commercial ice harvest from Walden Pond occurred in 1930, symbolically ending an era that had begun more than a century earlier, when Frederick Tudor first conceived of shipping New England ice to distant markets. Thus concluded the Age of Ice Cutting in America, the great industry that had employed tens of thousands, sustained entire communities, and transformed the way people lived and ate simply faded away. The ice houses stood empty, the cutting tools gathered dust, the knowledge passed down through generations, slowly forgotten. Where once the sound of ice saws had echoed across frozen lakes, now only silence remained. The last ice cutters, their work finished, walked away from the lakes, leaving behind only memories of a time when winter itself was harvested and sold. And so, the ice-cutting era came quietly to its end. Thank you for studying with the Sleep Scholar. May your dreams be filled with quiet knowledge. Sleep well, and we'll see you in the next lesson.